video, we're going to do solving rational expressions, just some more examples, okay? Get a little bit more practice. I know this topic is a little bit more confusing, right? So v squared minus 5v, we can factor the denominator, right? Remember, the steps are you want to factor the denominator of all of the fractions. That way you can see which factors are missing for which fractions, and you can multiply those factors in. So notice that both of these two fractions already have the same denominator. We just have this fraction that's missing v minus 5. So I'm going to multiply v minus 5 to top and bottom. Remember, once those denominators are all the same for all the fractions, they just cancel, right? Essentially, you could view it like you're multiplying in that denominator, but when you multiply and something is in the denominator, it ends up canceling, right? If I have a 5 in the denominator, I multiply by 5, that cancels. So as long as it's the same on all of them, they just all cancel. So I have 1 times v minus 5, so that's v minus 5, and plus 3v plus 12. And I really don't need the parentheses here. So let me just rewrite that as v minus 5. And that's equal to 7v minus 56. So combining like terms, 1v plus 3v is 4v. Negative 5 plus 12 is positive 7. And on the right-hand side, we have 7v minus 56. Let's go ahead and subtract 4v on both sides to bring it to the right, and add 56 to bring that to the left. So on the right-hand side, 7v minus 4v would be 3v, and 7 plus 56 is 63. Then divide by 3 on both sides. We end up with v is 21. All right, let's go back and check, make sure our excluded values, v cannot equal 0, and v cannot equal 5. So these are our excluded values. We're good. All right, let's work on number 9, and then I'll give you a chance to pause and try 8 and 10 on your own. So here we have 1 over n minus 8 minus 1. So you got to remember that 1 is a fraction. It's just 1 over 1, right? Now the denominator of both this first fraction and this last fraction that's on the right-hand side of the equation are both n minus 8. So really we're just missing for this fraction n minus 8 on the bottom. So I'm going to multiply top and bottom by n minus 8. So essentially we have n minus 8 over n minus 8, which is just 1. But the goal is, now that the denominators are all the same, they cancel, right? All of these cancel. So we end up with 1 minus, and I'll distribute the negative to both of those. Negative times n is negative n. Negative times negative 8 is positive 8. And on the right-hand side is just 7. Combining like terms, 1 plus 8 is 9. And I can bring over the 9 by subtracting it on both sides. So we end up with negative n equals negative 2. And divide by negative 1 to get rid of the negative, n equals 2. Let's go back and check our excluded values. Our excluded value, n cannot equal 8. So we're good. This is a good solution. All right, so go ahead and pause the video now and try number 8 and 10 on your own. Okay, so go ahead and fast forward and see if you got these two right, but let me go over it. So if you're coming back to see how it's done if you didn't get it right, let's go ahead and factor all the denominators. So m times m minus 1, that's how that one would factor, and these two are the same. We could factor out an m, that gives us m minus 1. So now that the denominators are all factored, I see that there's a factor of m on all of the fractions, but I'm missing the factor of m minus 1 on this middle fraction. So I'm going to multiply the middle fraction by m minus 1. Now that the denominators are all the same, they all cancel, and we end up with 1 plus m minus 1 equals 5. Okay, 1 minus 1 cancels, so m equals 5. Great. Let's verify our excluded values. Excluded values, m cannot be 0, and m cannot be 1. So we're good. This is the solution. Pretty easy. Let's move on to number 10. All right, factoring this one, it's a trinomial, so multiplies, the coefficient is 1, so it does make that a little bit easier. Multiplies to 10, adds to -7, -5 times -2, -5 plus -2. So this will factor into r minus 5 times r minus 2. Okay, we already have the factor of r minus 2 on both of these fractions, the first one and the last one, so we're just missing a factor of r minus 5. So I'm going to multiply top and bottom here by r minus 5, and I'm going to multiply top and bottom here by r minus 5. And I'm going to erase a little bit because that's looking like not an r anymore. There we go. R minus 5. Okay, so now that the denominator is the same, you guessed it, they all cancel. So the numerator, 1 times r minus 5 would be r minus 5. Plus 1, of course, is just plus 1. And 6 times r is 6r. 6 times -5 is -30. Okay, combining like terms, r minus 4 equals 6r minus 30. Let's bring 1r to the right by subtracting it, and bring -30 to the left by adding it. So we end up -4 plus 30, which is 26, equals -6 minus 1r, which is 5r. Dividing 5 on both sides, we get a solution of r equals 26 over 5. Let's go back and check our excluded values. Our excluded values would be r cannot equal 2 or 5. Now 26 over 5 is not either one of those, so this is a good answer as well. Okay, let's do one last example together, and then you got one last check on your own. So we have a problem here, and it asks which of these is the correct statement, right? Now notice that here they are adding top plus top over bottom times bottom. And you can't do that, right? In adding fractions, you need a common denominator. So the denominator here is b and the denominator here is a, which means I would need to multiply this by b and multiply this by a so that the denominators are the same. And I would get a squared over ab plus b squared over ab. And now that the denominators are the same, they stay the same for my final result, and I just combine and add the top. So here I end up with a squared plus b squared over ab. That's not this one, and it's not this one, or C. Our correct answer would be D. Okay? Now go ahead and pause and try number 2 on your own. Okay. So with this one, they ask us to consider the rational equation, and they ask us, are there any extraneous solutions? Okay, so that's the question. Not solve, not what are the solutions. They're asking us, are there any extraneous ones? Now, remember that extraneous solutions comes from a solution that you get that was initially an excluded value. So stating the excluded values is not the question here. Right? It's not just what are the excluded values. The excluded values would just be whatever makes any of these denominators 0. We are going to have to find the excluded values. Let's do that now. Now let's factor to find that. So this would factor into 3x times x plus 4. So we have a factor of x plus 4, so x cannot be -4. And we have a factor of 3x, so x cannot be 0 either. So these are our excluded values. Now that doesn't necessarily mean that there's an extraneous solution. That just means that those are the values that x cannot be. We have an equation, let's now actually solve it to see if any of the solutions are one of the excluded values, and that would be the extraneous solution if there was one. So I'm missing here in this fraction a factor of 3x. So let me multiply top and bottom by 3x. And for the 1, I'm missing the whole thing, right? 3x times x plus 4. So essentially, I'm going to write this out on the bottom here because I'm running out of space. So essentially, I'm multiplying the 1 over 1 I'm multiplying it by the 3x times, 3x times x plus 4. Now when I multiply that to the numerator, I am going to have to combine the numerators, so it will be easier to just multiply the simplified version of that, which would be 3x squared plus 12x. For a second fraction, we had to multiply by 3x on top and bottom, so we get 3x over the x plus 4 times 3x. The denominators are all the same, so they all cancel, and we end up with 12 equals 1 times anything is itself, so we get 3x squared plus 12x, and minus 3x. Combining like terms and bringing over the 12 to this side, we would get 0 equals 3x squared plus 9x minus 12. We could then factor out a 3, which gives us x squared plus 3x minus 4. And the coefficient here is 1, so to factor that one is very easy. Multiplies to negative 4, adds to 3, would be 4 times negative 1, 4 plus negative 1. So this factors into x plus 4 times x minus 1. So we have two solutions, x equals negative 4 and x equals 1. Now remember, the original question is, are there any extraneous solutions? So if you look at the excluded value, negative 4 is an excluded value, and we got that as a solution. So this is an extraneous solution. This is not actually a solution. The only solution would be the 1. So what is the answer? The answer is yes. There are extraneous solutions. Why? Negative 4 is an excluded value. And of course, a part of the justification is all of the work. All right, so hopefully it was a little bit better this time around, and that helped. I'll see you guys next video.